Good evening, everyone. My name is Lalita Sagari, and today our internship is powered by Emertxe, and this project title is IoT based on home automation. So these are the contents. I'm going to cover about the topics that we have learned during the internship and what is IoT, IoT architecture, what is embedded system, project requirements, project output, and then followed by the conclusion. So these are the topics that I have learned during the internship. So in the C programming, uh, we have covered the concept of the keywords. There are totally 32 keywords in C, and the basic data types such as integer, character, float, double, and void operators, conditional constructs such as if loop and if else ladder, and then looping concepts include for loop, while loop, and do while loop. In the concept of arrays, we have learned how to store multiple variables of similar data type in a single dimensional or multi-dimensional. And regarding pointer functions, we have known how to work with built-in and user-defined functions, and later on the storage classes, preprocessor directives. In this, we have learned to link the present file with the source file by using a hash function and then the header files. In the C++ programming, we have covered the OOPS concepts, constructors and destructors. Well, OOPS concepts are the object-oriented programming concepts. And then regarding IoT, we have covered the introduction, definition, and IoT architecture. And then embedded systems, its introduction, definition, types of embedded systems, components of embedded systems, and also the peripherals such as LED, Arduino Uno, CLCD, and ADC. Well, the peripherals required for the project are LDR sensor, temperature system, and the serial tank. In the LDR sensor, we have to read the sensor values, and based on that reading, the LDR brightness will change. In the temperature system, the LM35 temperature sensor has been used to read its temperature from the surroundings. In the serial tank, well, by using the serial communication process, we can read the volume of the water in the tank. And what is IoT? IoT is a Internet of Things, which is a network of physical objects that interacts with the external environment. Well, these devices range from 7 meters to 70 meters, which covers all the aspects of the household and the industry purposes. There are multiple advantages with this Internet of Things. In that, low cost computing, the cloud, big data analytics, and mobile technologies are the major ones. And another special feature with this IoT is that it can share and collect data without any human intervention. So this is the architecture of IoT, which includes the sensing layer, network layer, data processing layer, and the application layer. In this sensing layer, there are multiple sensors that collects data from its surroundings, and this collected data is sent through the gateways of Wi-Fi or the Bluetooth module. Well, after that, the processing unit will receive the data through the wireless communication, and it enhances the data, and then it sends to the targeted devices in the application layer. So, what is embedded system? Well, it is a combination of hardware and software that are designed to do a specific task. Well, in the right hand side picture, there are multiple applications of the industrial robots, GPS, receivers, and so on. These are all the applications of the embedded systems. Well, these are all designed to do only one task, that is repeatedly and simultaneously. Well, these are designed by using three parts such as software, hardware, and firmware. Let us take an example of an industrial robot where the pick and place work has been coded by using a software, and its design is done by using a hardware components such as servo motor or either the 3D printed parts. Well, if these embedded systems are compared with the supercomputers, then these are of no use. That means they can only perform to a limited extent, and that is also for a specific task. Whereas for a supercomputer, they can analyze the data, visualize them, and they can modify their way of performing the task. Whereas the embedded system cannot do that. So these are the project requirements. that is to control the garden lights on the basis of sunlight intensity, and then the temperature system control, where there are two switches, heater and cooler. If the temperature exceeds to 35 degrees centigrade, then we have to switch off the heater automatically. Then the water tank control. Here it contains two switches, inlet and outlet valve, which works remotely by setting a value of 2000 liters. These are the requirements of the project. The hardware includes the Arduino Uno Ethernet module, PC of 8574, and the other sensors. And the software requirements are the Arduino IDE, Pixim Lab for simulation purpose, null modem emulator to configure ports of serial remote tank, and Blink IoT app for cloud server. The Arduino Uno. This is based on Atmega 328P microcontroller. This is considered to be the easiest boards of all because it is easily programmed by using IDE, that is Integrated Development Environment. And then here is an Ethernet module. Well, it provides easier internet connection to the embedded system, and it supports power down mode, and it also supports high speed serial peripheral interface. So this is the diagram of the Ethernet shield, where the right hand side D0 to D15 indicates the data pins, and the left hand side bottom A0 to A5 indicates the analog pins, and the V into NC indicates the input voltage, ground, 5 volts, 3.3 volts, and etc. And here is a temperature sensor. The right hand side diagram shows the temperature sensor LM35, which contains three pins, namely input pin, output, and the ground. The input pin takes a voltage of 4 to 20 volts, where the left hand side diagram shows the PCF 8574. It is a general purpose remote input output expansion for many microcontroller families, and it contains an 8-bit quasi bidirectional port. So this is an LCD which is used to display the temperature and volume of the tank, and here it contains 2 rows and 16 columns. The LCD stands for liquid crystal display, which is in the form of a dot matrix. And here is an LDR sensor. This sensor is used to sense the values, and it changes with the light intensity that falls upon it. Well, the resistance of a photoresistor decreases with increasing the light intensity. So these are the project screenshots that I have been taken while working in this project. So here is the LDR sensor. Here the LDR sensor has been set up to high value. So the the LED is brightened, and here the LDR sensor value is dropped down to 0. So that's why the LED is off. In the similar way, here the cooler is on. It is indicated on the LCD display. The cooler is off. And here the heater is on, and it is indicated in the LCD display as shown in the screenshot, and here the heater is off. Well, T shows the temperature and V shows the volume of water in the tank. So this is the serial tank picture, where the upper part shows the inlet valve and the downward part shows the outlet valve. So here the inlet valve, whenever it is turned on, it is indicated in a green color. Whenever it is off, it is indicated in a red color. In the similar way, the outlet valve is present at the bottom, and these are the screenshots of the Blink IoT app. And here there are two tabs. Mainly one is for the temperature control, and the another one is for the serial tank control. So here it contains heater, cooler, and a temperature gauge meter, which is of 0 to 100 degrees centigrade. So whenever the value exceeds to 35 degrees centigrade, automatically the heater and the cooler are switched off automatically. And then the tab 2 contains inlet valve and outlet valve, and also the water volume gauge meter. Here, whenever the inlet valve or outlet valve is on, the serial tank starts to fill the water automatically. So whenever the inlet valve reaches to its highest value, it automatically stops. So these are the outputs of the LDR and the serial tank. So if we see the video, here the values are changing and the LED is also changing along with the change in the LDR values. And here, as I said earlier, whenever the inlet valve reaches to its highest limit, then the inlet valve will be automatically turned off.